show it again. And we will be actually posting it on our website as a link of the recording so that you can watch it again. And then we have some guidelines. So this actually says to, I prefer to actually have you ask questions as we're going and to just unmute yourself. If you want to mute yourself while we're talking, that's fine, but please then unmute yourself and ask any questions. Plus, I like to ask you questions, so this way you can actually just unmute yourself and answer the questions while we're going on. And there will be a survey at the end, and we really appreciate any feedback you can give us to help us continue developing our programs. So I'm Kate Kozak. I'm one of your presenters. I'm from Coconino Community College in Flagstaff, Arizona. Danny, do you want to introduce yourself?
Oh, I'm Danny Kaplan. I'm at McAllister College in St. Paul, Minnesota. I'm the person who writes these little apps, and so getting feedback about them is very important to making them actually useful.
All right. Laura Ann? Do you want to introduce yourself?
Sorry, I muted myself. Started talking and forgot that I muted myself. I'm Laura Ann. I'm with MAA Programs. Nice to meet you all.
So if you could also introduce yourselves and just let us know what your name and college is, that'd be wonderful.
Maria Burness, Carroll Community College in Westminster, Maryland.
Janice Stencil, Carroll Community College in Westminster, Maryland as well.
All right.
Wonderful. Has anybody else joined us? All right. So what we're going to do today in this webinar is we're going to kind of give an overview of our StatPREP website. I'm assuming since you are going to be at the workshop that's going to be this summer for the first time, that you haven't actually spent any time with our website. Is that correct?
That's correct.
Okay.
Yeah.
So we'll go through a little bit of the website of what information is available to you. And then we're going to show you some redesigns of the little apps. Since you haven't seen them, you won't really notice that they're redesigned, but we'll show you the features of it. And then, like I said, we'll go through the little app, little linear models. I'll show you how I would use it in my classes, and then we'll talk about how we assess it, and then, of course, any questions you have. But please feel free to ask any questions during. That's a better way to get your questions answered, is to just let me know when you have one. All right, so let's go and look at the StatPREP website. So statprep.org is our website. It's really easy to get to. You just statprep.org. And when you get there, you'll see information about our StatPREP. We have, on the home, we have a little bit of a blog that will give you information of announcements that are coming up. We also happen to have information about our different workshops, so you can find out more about it. So let's go look at the one that's actually in the Washington, D.C. area. So you can see who's doing it at Howard Community College, and her contact information and the dates. And so all of the workshops are listed there. Then we also have our webinar series. If you click on that link, it'll show you all the different webinars we've been doing and all the recordings of them. So past webinars if you want to see more information. Some of them are more about how to create your own lessons with R. Some of them are about how to use some of the things that are already created for you. And so if you didn't see one of these things, you want to know what the What's Normal class lesson is about, you can watch this webinar just by clicking on the link. And then to apply for a workshop, you just click on the Apply for a Workshop. We are taking applications right now through April 17th. So we really would love to see you at our next workshops. I'll go on to resources in a little bit, but About gives you some information of where did StatPREP come about, who the team is, how MAA and StatPREP are connected, how AMATIC and StatPREP are kind of connected, and how ASA and StatPREP are connected. So this gives you all of our affiliations that we have. And then we put out newsletters every once in a while. So you can see, if you click on here on newsletters, you can see all the different newsletters we've put out so far. We'll put new links whenever We have a new web newsletter out. You can see the old ones here. But let's go to resources. We have different resources available to you. We have the little apps, which is what we're going to show today. We have class lessons. I'll just click on this to show you a little bit of what they are. These are ones that you can actually use in your classes. Gives you an idea of kind of what you could do, first day lesson. And you don't have to do it on the very first day, but it's an early semester lesson. So is the riverboat card trick. That's also an early lesson. So is the collecting data with the globe toss. That's also an early lesson. Then we also have how to do an experiment you can do with paper airplanes that your students can create in class. We have the what's normal that shows the normal distribution and some of the ideas behind it. And then we have a proportions and medical screening one for conditional probabilities. So those are the kind of the lessons we have. Also under resources, we have tutorials. These are information about the different tutorials we have that are available to you. These are mostly for things that for you to learn information, but also some of these you can use in your classes. So we have something that talks about introducing to data tables and what is a, the name just went from me. Danny, what's the name of data tables? Clean data, right? Tidy data, there we go, tidy data. And then basic vocabularies of R. So this can give you kind of an idea about what R is like. We do a lot with the R program, and mostly because it's being used out there in industry, so we want our students to be exposed to it a little bit. Then we can show you how to do certain graphs, statistical calculations, and then even some sampling and resampling and shuffling information. I just use the shuffling to introduce my students to hypothesis testing. So even though it's for you to also learn these things, you can also use them in your classes. We also have some data sets suggestions because we're always hearing people ask, where do I find data sets? So these give you some information of where some great data sets are. Our World in Data is a new site that's out there. It's got incredible amounts of data for you to look into. And then we have some information about our workshop and hub leaders. So these are the people that have done workshops in the past. So that if you've gone to a certain workshop, you know who to connect with. And then we also have our different hub leaders information there. So we're going to go into the little apps. So under resources, again, go to little apps. And this gives you an overview of what the little apps are, what they're about, and then a little bit about the redesign because they have changed recently. So this gives you a little bit of idea of that. And then we have different little apps. We have Center and Spread, gives you an idea of kind of looking at having your students see how the center and spread work together. We have one on the 2-sample T, which I'll be probably using in my class very shortly, since I'm at that point. We have one on proportions. I'll probably also be using that one in my classes very shortly. And then we have the linear models. And then we also have resampling and bootstrapping. So this is another one that we just created that gives students an introduction to this new, not new, it's actually a very old method of doing statistics, but new to the nomenclature that's out there. But we're going to again go into the linear models one. So you can either click on the picture and then I'll take you there, or you can click on the link. If either one is fine. So I clicked on the link, just have to wait for it to come up. All right, so this is what our little apps look like. We have different data sources. Not all of them have the exact same data sources, but they have multiple data sources. So under here we have health, which gives you, if you want to know more about each of the different ones, you can go to what we call the code book, which is one of these tabs over here. And it'll talk to you about what this data is. So the health data is the U.S. National Center of Health Statistics has conducted this series of data, and they've collected information that we can use. It's also, if you're in R, it's called the NHINES package. So you can use this data set, and then you can actually use it in R because it's built into the R, one of the R packages you can install. The other ones, we have Galton. Galton data set is actually, was basically from the 1880s, and it was a way of him to kind of look at traits of people. And so we have this data looking at, and we can look at the different data with it. We also have births, 2014. This is actually from the CDC. So they actually collect data on all the births in the United States. And so we actually have it for the 2014 data set, though they have it for all the years from, I don't remember exactly when it started, but
about 1990 onwards, the files are available.
Okay, what's the date? Sorry.
About 1990.
About 1990? Okay. And then we have the CPS 85, which is also, it's a current population survey from 1985. So this is actually, again, from census information, and we'll give you some information and data we can look at. We have diamonds, which gives you some idea of kind of how diamonds are related to each other and what the cut would be and how much they would go by, how much they would be selling for. We also have SAT data. So this is our, actually, you know what the SAT test is, obviously. And so this is the data from the SAT test. State by state. And so those are the different data sets we're going to work with. We're going to go ahead and go into births today and look at some of the births information. So the next thing you can see is down here.
If I could just point out, if there's a data set that you'd really like to have in this apps, let me know, because it's straightforward to add them in.
Yes, so thank you, Danny. That's wonderful to know. So anybody can actually add those. We can put them in. Just let us know we want to have those. And back in the StatPREP website, our information's in there under either the hub leaders or under the StatPREP information. So now under here, we can pick different variables. Right now we have mother's age picked and we have father's age picked. And you can see that usually, because they're about the same age, usually a mother and father would be around the same age. And you can kind of see that there's a nice correlation going on here. I need to find where to put this. All right. All right, so, and you can see kind of what's happening with those. We can also pick in covariates if you want to do that. So we can have some different covariates to look at that we can work with. We can also pick different ones. So I think more interesting would be baby's weight. Obviously with father's age, when we put in baby's weight, the father's age doesn't seem to make any difference. We have almost a flat line here. In fact, almost slightly a negative correlation. And really, if you think about it, father's age and baby's weight shouldn't have anything to do with each other. So we can pick a better variable. If I could do mother's age, I can see a little bit more of a relationship going on. It's a slight increase going on. And we can kind of see that. And you can actually have your students pick which variables might be of interest to them that they'd like to look at. So I think what would be more interesting is maybe looking at gestation. How long were they actually, how long was the pregnancy? So that might be more interesting, and we can see that there does seem to be a positive slope going on here. These dots are the actual data points. So this is actually one person's gestation age and their birth weight. So you can see these different values. So this dot right here is some other child's gestation age and their birth weight. And so you can go along here and look at those different things. This child obviously was born really early, which makes sense that their weight was really low. This one's interesting that this one was obviously born fairly late, but still has a fairly low birth rate. So it makes you wonder why that could happen. So those are things we can look at. But we can also, over here, we can do a covariate if we want to. So looking at whether or not they were induced. And when we do that, we can see we have induced no, which would be this red line. And we have induced yes, would be the blue line. And so you can see, hey, is there a relationship? Does this actually make a difference that they were induced or not induced. Looking at this, not induced doesn't look like it has much of a slope at all. Induced has a little bit more of a slope. So there might be something there, but we can go back to just none and go back to the idea of our data set. Over here in this sample one, we can actually pick a new sample. So what they've done is we've taken 100,000 births, and we are taking a sample of 50 from those 100,000. And so we can actually take a new sample of 50 from the 100,000 and see how things change. And so when I did that, you notice, well, what did you notice just happened? Anybody want to say what they thought just happened when I took a new sample?
It didn't really change that much.
No, it didn't change a whole lot. The slope changed ever so slightly, but not a whole lot. And you can also change the size of your sample. So if you don't want to do 50, if you want to go to, let's say 2,000, you could do that. And then you can see, so now what happened when we did a much bigger sample?
The slope appeared to change.
Yeah, the slope did appear to change a bit
Looks like
when
it
we did
increased.
that. Go ahead.
I'm sorry, I said it appeared to increase a bit.
Yes. Could that really be a real factor, or could it be a factor of the size of the sample? So this is where you can bring in that discussion of just large samples can actually create things that we don't actually think are real, just by taking a very large sample. Let's go back down.
Well, hold on. Everything is real there.
That's real. Yes. I'm sorry.
All right. So one of the things we've tried to use is real data. And real data doesn't always behave the way doesn't always behave like elliptical clouds, like textbook data. And here, what you see, if you could do more than 2,000, do 10,000, something like that. Here, what you can see is that, when it comes up, is that the cloud looks like it's got a main part, and then it's got a long tail.
Yes.
And why it can be a question to ask the students, why is there that long tail? What does that mean in terms of the reality of babies being born?
So those would be discussions we could go through. Let's go to a much smaller sample so we can kind of look at some of the other information that goes on. We'll just do a sample size 10 at the moment, just so I can show you some of the other features we have in the little app. So under here we have model controls. So down under the sample we have a model controls. We can show model values. Danny, that didn't seem to...
It did. If you look very carefully, you'll see a little triangle along...
Oh, there it is. Yes.
the line.
Yeah, so it's just showing you what the values would be from the model, from the actual line. So, when you're in classes, usually we come up with a regression line, and then we have our students calculate for certain values, the Y value for certain X values. So this is just showing you those values on the graph. The trace vertically, I'm going to turn on for just a second. You don't see a whole lot here, but you can kind of see it when you look closely. There's some vertical lines here. So right here, you can really see that vertical line, and here you can see it better. That vertical line is showing you the residuals. So it's just showing you the difference between what the model predicted and what you actually measured. And so that's a nice feature to show when you want to talk about residuals. You can really show your students what those are. The trace horizontally, I'd like to show you a little bit more about. So what this is actually doing is taking those model and kind of tracing over. So we came up from an X value, from our independent variable value, or what I like to call the response variable, and then came up and found what the explanatory variable would be with that. And you can see where they are and what they fit in. So let's talk about what these lines are over here. This kind of T-looking blue T here, and this black T here with the red. The red lines represent what you actually did measure, And the black lines represent what you actually calculated the values to be. So we can compare how well they did that. And you can see variability-wise, we seem to be matching pretty good. This blue T-looking thing, actually, I guess it's more like an I. This blue eye-looking thing represents the amount of explained variation that is in the information in the model, and this line is the amount of variation total that there is in the model. So you can actually look at the ratio of the explained to the total. So it looks like my explained is about, I don't know, it looks like about 80% of the overall. Is that what everybody else is kind of thinking?
Yeah, that looks about right.
Yeah.
Yeah, I
So
was
we can
guessing
actually,
75%.
what was that?
I was eyeballing 75%, so yeah, I'll go with 80.
Okay, 75% is great. So that is your coefficient of determination. That is R squared.
No,
So
that's
you
R.
actually can find R squared directly just showing your students kind of visually what's happening. So now let's actually go down and see what actually is happening. Can we actually calculate that R squared value? So that's what I like to do with my students, is kind of get them to visually see R squared value happening, and then let's actually go calculate it. And so down here, I forgot to talk about these, but we have an explain thing that kind of talks about what regression is about and gives you information about these concepts I'm talking about right now. And we have the code book, which we talked a little bit about, but it also tells, if you go down, you can see what age of mother actually represents, what induced actually represents, what ventilator actually represents, and all these different ideas and what they actually represent. And what the variables actually are. And that's useful for students to see. And if we go to statistics, we will actually find the little r, which is just the correlation coefficient, and the R squared, which is, in my opinion, a little bit more interesting. So the little r actually is what we calculated. So about 70%, somebody said. I thought it was about more like 80, but it looks like it's about 60.689 is what it looks like. And that value there is actually the square root of the R squared, which I realize is R, but correlation coefficient isn't as useful as the coefficient of determination. But looking at this, it does look like the R squared value is about 0.47 or 47%. And so we get that information. And you can also go down and you can find your p-value. So does this look like it's significant? Like there is actually a relationship between these two? And the slope is significant?
Well, usually we compare to 0.05.
Right. So what do you think? Are we significant or not? With that value right there. Again, I like to ask questions and with my students, so I don't ever actually lecture to my students. We usually have discussions in classes with things. So it looks like, because it's compared to 0.05, it does look like there is a correlation, that there is actually a slope, a positive slope in this case, between the baby weight of somebody and how long the pregnancy lasted. And so you can go down and you can see the regression tables you get from R. If you happen to use ANOVAs instead, you can see the ANOVA information is here also, depending on which method you teach in your classes. We have both of the information for you. If you want to know actually what the commands were that created this in R, we can click on R commands, and it actually will show you how to create this in your R program. So if you want to actually make the same kind of information with your own data set, you can see how to actually create this. And I actually give my students these R commands, and they do these in classes all the time.
But this doesn't mean you need to use R with your students.
Right.
It's just, if you want to do that, this is the connection between these apps and R.
Yes. So it just gives you that information to have that. I do use R with my students, but I've known other people that just show the little apps and don't actually show the students how to calculate it. They're still doing things with other methods for doing that, which is fine. One thing I will point out, though, that I know a lot of teachers use graphing calculators. And with these data sets, we've got 100,000 data points in here. That's a pretty big data set for your students to actually work with on a graphing calculator. So that's why I try to use R instead of some other thing. So we've got this information. We can see a nice graph going on here. We can see a significant relationship. Let's look at some other variables. And that's what the beauty of this is you can actually pick other ones to look at. So another interesting thing, when my son was born, one of the things they paid attention to was the ABCAR score. And so you can see kind of how the baby's weight and their ABCAR score is related. And if you don't actually know what the ABCAR score is, again, you can go into Codebook and go down, and you can read that the ABCAR score is what they score the babies 5 minutes after they're born. And it's a series of different tests that they do to see whether the baby's healthy. The closer it is to 10, the healthier it is. I know in my city, nobody can be as ABCAR score better than 9 usually, just because we're so high. Their oxygen level is so low. But you can see again what the ABCAR score is related to their baby weight. And again, now we can see this is again the explained variation. This is the total variation. And so looking at this, what does this look like might be the square root of the R squared value by looking at this ratio. So how much of this, what percent of this is this big one?
It's so hard to tell on a small screen, but I would guess maybe 25%.
Okay, so let's go look at the statistics and see how you were. Go ahead. I thought somebody said something. So looking at that, you were actually really close because it looks like the R value is 0.27. So that's not bad. Yeah.
Hey, can I
pretty
step
good
in for a second?
Of course.
Okay, so there are some aspects of these apps that might seem odd. Usually in introductory statistics, we talk about bivariate relationships, right? So baby weight and APGAR 5. But we're avoiding that terminology because it's not one that's used really in professional practice, right? In professional practice, you build models of things. And so there's a distinction between the two variables in the bivariate relationship. One of them is a response variable, the output of the model, and one of them is an explanatory variable. And in our introductory class, we hardly ever talk about covariates, which maybe you would be more familiar with the word confounder, although that's a particular kind of covariate. So we're trying to use that modeling language explicitly. And every app that you look at will have a graphic which is based in the data, which is the response variable on the y-axis and the explanatory variable on the x-axis. And we always try to use real data. And the sample that Kate pulled up, well, that's kind of interesting. Don't change it yet, Kate, but that's kind of interesting because essentially every baby is a 9 APGAR, except there's one who's a 5. And if you wanted to talk to your students about influential points, how influential do you think that 5 is, that APGAR 5 is? Right? That's got a huge amount of leverage. And so what you can do is to show them the variation that arises in sampling in terms of the model. So Kate, if you click a new sample, see now we have a 7 as our lowest one. Now the slope is negative, right? The little r is 0.22, but negative. And you can do this over and over again to get an idea of how much variation there is. So there's going to be a lot of variation in these very small samples. But if you go to a large sample, what's going to happen?
You get a lot.
First of all, we're getting a little r of close to 0. And you could just play pressing the sample button for for that. You get an idea of how much spread there is due to sampling variation and how big an effect needs to be for it to be significant. Okay, that was my editorial.
And I thank you for that, because that is actually a very important thing to look at. So actually, I would like to pick a different data frame, because some of my students get a little tired of baby stuff, because we do a lot of that in my class. So let's go look at the SAT tests. So this is actually how much is being expended by the states per student. And then let's actually look at their math scores. And so what do you notice about this?
It has a negative slope.
Yes. Yes. So what does that tell me?
As students get smarter in math, they spend less on education.
Yeah. So is that surprising?
No.
Not really.
Not really? So you think that states that spend more on education actually are wasting their money because it doesn't actually improve their math scores?
Okay, maybe you want to reverse the response and explanatory variable.
All right, let's do math and expenditure.
There you go.
So now states that spend more on education per student have worse math scores.
Well, we live outside Baltimore City, so I find that basically to be reality.
And I live in Arizona, and I don't find that to be reality.
Really interesting.
But there's this thing that goes on in my state, is that who takes the SAT test?
Typically, the college-bound students take SAT.
Yes. So if schools don't spend a whole lot of money on their students, like over here, then who's taking it? Which are these students? Who are these students, I should say, that are over here? Because this is actually the average for each state. So this isn't the average. This isn't individual student. This is the average for students in that state. So what does this tell you about the students that are in states that don't spend as much? Who are these students that are taking the test? You were just said it, but let's talk
we don't
a little bit
know
more.
from this graph because that's just showing us for those students.
What was that?
The dot is just for the students who happen to take the test.
Right.
So we don't know yet.
Who are those students? They're the ones that are college bound.
And you said it's an average for a state?
Yes. So Arizona is probably this dot right here, because I think we are the lowest expenditure. And so most of our students who are taking this are the ones who are college bound. And would they be the ones that would do better on the math, do you think?
Most likely.
Most likely. Whereas on states where they are doing it more, who are these students?
Well, if the premise is that it's the only the college-bound students who take the test, I'm a little confused, I think.
Okay, so it could be that there's more college-bound students, more students in states that spend more. And this is just a theory, but states that spend more per student might actually have it be where more students take the SAT test because they actually are encouraged to take it and encouraged to go to college. Even if they're not necessarily, they wouldn't be college-bound students in this state as much because they're not encouraged as much. So it could be that more students in these states are encouraged to take the SAT test than in states that spend less. That's just a theory.
How could you test
And
that?
aren't you changing the variable a little bit there?
I am changing the variable a little bit here, yes. But how could I test that? That's a good question. So I don't know how I could test it. I would have to get more data to find out. Let's see what other things we can check on. So we could actually look at the ratio of students who take the SAT test compared to the expenditure.
Student-teacher ratio.
Oh, that's the student-teacher ratio. That's right. So the fraction. There we go, fraction. So these are the fraction of students that take the SAT test compared to the expenditure. So now, how many students, this looks like about 76% of the students in states that spend a lot per student take the SAT test. Whereas here, for states that don't spend a whole lot, it's more like about 12%. Right?
Mm-hmm.
So that would be a good thing to look at. And this is where we have these different variables we can look at that give us information.
So in that graph that you had originally, the math versus expenditure, you're saying that there's another variable coming into play here, which is who takes the test.
Right.
All right.
So what were you going to say? So then what might be useful is to look at a covariate as what are the other variables. So that's where you can start talking about covariates. Normally with our classes, because we're doing anything either on calculators or by formulas, we don't get to look at these other variables. So we can actually put in, let's do a ratio, not ratio, it's frac. Let's look at the fraction, and we can actually divide it up. So here we have the fraction of students that are taking the test that are in between 4 and 11%. This one is 11 to 57%, and even higher than that. So you can see these different values. The yellow, I have to admit, is a little hard to see. But what do you notice about these three graphs? These three lines?
Well, two of them appear to be parallel. Yes, the yellow's quite hard to see on my screen, but and then that middle line, I don't know if it's blue or what color that is.
I think it's green.
Green, okay, is opposite, basically.
Right. So we suddenly see a difference in actually the slope of the line based on having this covariate. So it does look like states that have a higher percentage of students who take the SAT test actually do have a positive relationship between expenditure, math, and expenditure. So we can actually see that the states that spend more on per student actually do get better math scores if there's a higher percentage of students who take it.
So Kate, those dots are the same dots we saw before. They were black and we saw the downward sloping line.
Right.
And now you're telling us those dots are a mixture, right? Like that, same dot. And now you're telling us those dots are a mixture from states that are of different types.
Yes.
So if you put back up the color, so originally we were mixing together states where 70% of the students take the SAT with states where 10% of the students take the SAT. And those are probably very different students.
I would think so.
So here you're stratifying by the kind of state.
Yep. And so this gives you a way to actually look at this with your students and talk about that kind of relationship that's happening here. You can still see that there is a fairly high square root of r squared value because the ratio of this blue line to the black line is fairly high here. And again, if I want to go look at the statistics, I can see that my r squared value is 75%. My little r, you can't do it when you have a covariate, but you can use the r squared value, the coefficient of determination, to really see that, yeah, a lot of this is actually explained by these two variables together and this covariate. So it's nice, again, for a visual for your students to see it, and then you can put the numbers with it. I want to look at one more because it's kind of nice to actually see, and I'm going to do known. This one is where we're looking at the math scores versus the verbal scores. So what do you notice about this relationship?
There's a strong linear correlation between the two.
Yeah, that definitely is a very strong. And if I go down here and look at this, I actually see my p-value is 0. And so this is where I get to talk to my students that it's not really 0. It's just really, 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 really small, and R just rounds it to 0 at that point. And so we can have that discussion that even though it gives you a 0, it's not really a 0. And we can talk about, hey, that means that most of the students that do well on verbal also do well on math.
No, it doesn't.
No, it doesn't?
Average.
That's right, average. That's right. I keep forgetting these aren't students' values. These are average values. Thank you, Danny. So it's interesting to look at that and see that. And so it's nice to show them a fairly strong relationship happening here, strong linear relationship. If you haven't noticed, I try to stay away from the word correlation as much as I can. One reason is that I find my students use that word haphazardly and don't really have a good idea of what it means. And so I try to stay away from it as much as I can until I can actually give them a good idea of what it means. But they use that word even in probabilities. Oh, these are highly correlated. And so I try to stay away from the word as much as I can.
Can we look at the different kinds of states on this one?
Where do we do that, Danny?
Go to frac Q again.
Oh, that's right. Okay. So it looks, in this case, when we do frac Q, you can see, what do you see about these three relationships? These three lines.
They all have a positive slope. They all look pretty good.
Yeah. They all do look really good. They all look like they're pretty strong going on. So it doesn't look like what percent the students take it makes much of a difference, because it looks like there is still a strong going on with them. Anything else?
You get a hint there that the students in the low fraction states, their math scores are better, right, compared to their verbal scores.
That's true. There's a little bit of a hint to that, because the verbal scores, math scores are which one's the low? That's the purple line, right? You can say a little bit of that the math scores are higher. Okay. Anything else you want to look at here? So I was going to go back to where we are. So I want to talk a little bit about so we talked a little bit about the frames that are there, the different the graph you can get, the different tabs, but I want to talk a little bit about the assessment we can do on these. One of the things I do is I actually put the little app up, and I have the students pick the data frame that they want to work with and the variables they want to work with as a big group in class, and then we can talk about what they might have found, kind of what we're doing here. Put up the different values and have the students got to give an idea, so you can get a kind of formative assessment of, do students really understand what's happening or not happening? Or you can also let your students, if you have computers in the classroom, and actually the nice thing about this is all of this is web-based, so even a tablet will work. So if you don't have computers but you have tablets in your classrooms, they can bring their tablets in and do it that way. And you can put them in pairs to have them actually pick which variables of interest are between the two pairs, or even as individuals. And then they could talk about, with the whole class, what did they find? So that's the beauty of the little apps, is that you don't need R, you don't need anything besides a web browser. And then what I do is I actually give my students that link that was on the website that you can use to get into the link to the web little app. I give them that link. I put it in Canvas, and they can just click on that and get into it. I have noticed that if we have too many students on, that the little app slows down a little bit and has a little bit of issues. So I might make sure that it's just in pairs and not doing it as every single student in my class doing it. So to kind of cut it in half, but it works out beautifully, and they can talk about it. And summatively assessment, I could just give a test like I normally do over the linear models, because I'm not doing anything special here with this. I'm not teaching them R or anything with that, though I do in my classes teach them R, but they wouldn't need to do anything different. You could still give them your normal test. This is just to teach them about linear models. You could also give your students a data set and have them answer the questions for their data set. So similar ideas. You could give your students the output from R, and that's actually what I do in my class, because linear models is usually on my final exam, and that's an in-class test. And so I will give them what R would produce from a data set, and then they would have to answer the questions based on that output. You could also do what we did here, give that students the graphic showing those horizontal lines and have them calculate R and R squared from that graphic. So that's another way to kind of do a summative assessment that you could do in your classes. So that's kind of what I do with my classes, is give that information and go with that. So what I want to know is, I know we've been asking a lot of questions, but do you have any other questions you want to ask? And I should mention that I gave our email addresses here because you may think of a question as you start using it in your classes and go, you know, I really need to find out, what do I do here and what does this mean? And then you can write either one of us to ask those questions. So it's not like you have to have your questions today, but do you have any other questions you'd like to ask?
Okay, could you put up the little app again?
Yes.
Just so that we can see what
I
we're
think I
talking
can.
about.
Wait, let me see how to go back. Okay.
I have a question.
Uh-huh.
When we were working with particularly the baby data, the births, obviously ages and years, but like I noticed for weight, is there any place where it shows what the units are for each of the variables?
So in the code book, it does say that the baby's weight is in grams.
Oops. I see. Okay, great. Thank you. Because that's one of the things that we work with the students, because they ignore units. And so we try to get them to be cognizant of that, because just a number without any units is sort of meaningless. So just
Yes,
to get them a sense of a feel for what the values represent.
Yes, and I actually spend a lot of time on that same concept to make sure it's there.
I was really just looking to see what exactly can this app do, and you've done a lot with it today, and I've really like what I've seen so far. It isn't something that we're using yet, so maybe it's something we're going to move into in the future, but it is nice to have all this data at our fingers.
Yes, I agree with you, and the thing is that you don't have to use them all. I actually started off just using one of the little apps. And then I slowly started introducing other little apps into my classes because I want to get them to think differently. I don't want them to think about the data sets that are in our textbooks. I want them to think about data and what the data can actually tell them. And that's really the important thing, is to realize that data is not this 10, 15, 20, even 30 data points at a time. It's usually much bigger data sets, multiple variables. Normally in our classes, we have one, maybe two variables in our data that we work with. And this gets them to see, hey, there's actually more data out there that they can work with, and there's more variables in each one. And so that's what I like about it, is it gives them that idea. I also like the fact that I can pick a new sample and I can see how things change. And we can talk about, a lot of statistics is, I wouldn't say guess, but a lot of people don't like statistics because there's never sure what your answer is, but it gives them a chance to see that it is very dependent on what sample you take. And so it gives them a chance to see how the different samples can actually change things. And that's what I like about these little apps, is they give that students really involved.
Or less dependent maybe when the sample size is large. But one of the things I like about these little apps is that they're graphical. And my impression is that students in general do better with graphs than they do with formulas.
Yes.
So in assessing, for example, once students have seen that, if you could put up the model values there, show model values.
Oh, yes.
once students have seen that line and those between those little triangles and those black dots, it's actually a fair question to ask, what is the correlation coefficient?
Right.
You can see what the spread in the model values is, and you can see what the spread in the data is, and that's just the ratio of those two is just little r.
Right. And so it gives them a good visualization of what's happening. And that's what I like about it too. Is I agree. My students like to see the data. They like to see the graphs. They don't like to see numbers. They don't like to see formulas. And I've had my students in the past that used to teach it with doing everything with formulas. And I don't think they actually understood it any better just because they were calculating with a formula of what these things were. I think they actually understand it better when they can visually see what's happening. Which statistics is very visual. So I think it's useful and a good thing. So do you have any other questions you'd like to ask? Are there any other things you want to look at? I think this one's interesting, is what would the baby's weight do if somebody's actually smokes a lot? And what does that do?
Very little data. You need more data.
Yeah.
I think you also need to change your explanatory variable, because I don't know that the mother's weight correlates well.
It's funny, Kate, that you think 100 is more data.
That is true. I do. I think that is. Because I've been trained in all of my years of teaching that, that's a lot of data. But here's 5,000 is definitely a lot of data. And you can definitely see that it does seem to be, and we're doing baby weight versus gestation. And it does appear that that's an interesting, the cigarette thing is interesting. And then we can go look at the code book to see exactly what is SIG3 represent. And that's, again, how many number of cigarettes smoked daily during just the third semester. And so we could do it, so we could look at other things. The WIC might be interesting, is to see what that might look like.
Well, Kate, could you go back to the graph? So one thing you can ask your students, look, the different colored lines are different, right?
Right.
But are they really different?
No.
How do you know that?
Well, because they all seem to have fairly similar shapes. Slopes. They all have positive slopes. They're all about the same slope, a little different, but about the same slopes. Looks like.
Well, that might just mean that the effect is small.
True.
What if you go down to the stats table? Go even further down just to keep it short.
Yes.
Look, you do see that that the cigarette smoking makes a difference. Look in the ANOVA table.
So cigarettes in the third trimester has a P of that, and it's very significant.
So the one thing I like about that is that you can show that the statistics answer a question, not just show them the statistics, but show them the graphs and say, what do you think? What's going on here? How would you know?
Right.
And so the statistics are useful for something, not just something you have to do.
And that's true, because they do think that statistics is just, I got to calculate this. But it actually does answer the question that, yes, there does seem to be something going on with the third semester smoking.
So do your WIC, and let's look at the graph, and then we'll guess.
So now, does it look like there's a difference? This is either they're on WIC is the kind of greenish line, and they're not on WIC is the orange line. So what do you think? Do you think there does seem to be something about being on WIC or not on WIC?
Yeah, it does.
Okay. So now let's go down and
what's
see.
the story that you would tell?
Okay, yeah.
What story is suggested by that about the situation of people on WIC compared to people not on WIC?
Well, I mean, the lines are so close together, slope-wise. I mean, it definitely has a positive type of correlation with being with gestation and baby's weight. But the WIC part is interesting, where if they're not on WIC, they do tend to have higher birth rates towards the end of the pregnancy than it does when they're on WIC, which tells me there's a little bit of a malnourishment towards the end.
Of people on WIC or people not on WIC?
People on WIC.
Is that a surprise?
I mean, there's other variables that could go into that, but no, not really.
All right. And are they really different? You could just press new sample many times and see whether you consistently get the same result. Basically the same. Basically the same. Or you can do that as much as you like, or you can go down and show them where in the statistics table you see that you know that there's a difference.
So it does look like WIC does in fact create a difference because the P is so much smaller. So there does seem to be going on where WIC does actually make a difference in terms of baby's weight.
And in terms of the slope, yeah.
Yeah. Sorry, excuse me. So these are all things that you can actually have these conversations with your students and get them to start thinking a little differently about data than just calculating numbers and coming up with numbers. And then you can use the numbers here to say, hey, yes, you are seeing kind of relationship here. There does seem to be something going on between being on WIC and their baby weight. So any other questions? We're almost out of time.
Not so much a question. I just did want to say that I agree with what Janice said earlier in terms of this looks like a great tool, particularly to have access to these data sets that we can share in a classroom on a screen and have students explore and discuss, which is something that we haven't really had access to in the past. So this is really neat.
Good. I'm glad you're finding that useful. So let us know how things go when you actually teach with it. Let us know if there's anything you can say, hey, this doesn't make any sense, or I really like this part of it, or I'd like to have this data set available to me.
And one set of things that we do in the summer workshops is to take, I think, 6 of these little apps, of different little apps, and walk through an actual lesson with them. So to help give you an idea of how you might use these in teaching, or to see what ideas other people have, how to use them in teaching. So we're hoping that the workshops will be really useful.
I think that would be helpful because when you're used to teaching and approaching stats in a certain way and then changing that approach to be more visual, perhaps more exploratory like this with data sets, assistance in that area I think is greatly appreciated.
Yes, and that's what we're trying to do this summer is make sure that we spend a lot of time on that so you get a feeling like I can walk out of here and I can use this in my classes. I will admit the first time I used one, it didn't go great, but I was able to still use it, and I think my students learned something from it. So I would try something and try it. And we all have lessons that work great and lessons that don't work so great. So it's always nice to work out. All right, since we're almost out of time, I did want to go back real fast to this, just to make sure you go do the survey. So the Survey Monkey information is right here. Laura Ann, did you have something?
She's sent it in
I put it in the chat box for everyone.
All right, thank you. So go into the chat box. Please do this survey. That'd be wonderful. We'd be finding it very useful to find out what other information you have. All right.
Will do. Thank you so much. Appreciate your time.
Yeah, thank you for your time today. I appreciate it.
No worries. Thank you so much for attending.